All right, so this video is for the Unit 9 review problems. I'm going to do number 3 and 4, so that's page 2. Um, and they're both similar problems. They're both rotation problems. And you're trying to figure out where the new point is after a rotation of however many degrees. So in the first problem, we have a 34-degree counterclockwise rotation centered at the origin. So centered here at 0, 0. Which means that if I kept this going, I get this huge circle around 0, 0. And so that's going to be a radius right there. And this is also going to be a radius. And the rotation was 34 degrees. So this central angle would also be 34 degrees. So let's see. We take the point 43 and we end up where A prime is. So the goal is to figure out what A prime is. So let me get rid of all this extra stuff here. Okay, so just like every graphing problem we pretty much ever do, we're going to draw in slope triangles. So here are some slope triangles. And let's see, the rise part is 3. The run is 4. And so we can do Pythag to get r. So r squared equals 3 squared plus 4 squared. And that means r squared is going to be 9 plus 16, which ends up being 25. So r equals 5. Huh? I don't want that right. There we go. Hold on one second. Okay. We can also solve for, let me switch colors. We can also solve for this angle right here. I'll call that one alpha. It doesn't really matter what you call it. You can call it anything you want. And once I have alpha, I know that the angle next to it's 34. Really what that'll help me do is eventually solve for this angle right here. And I'll build a slope triangle that goes to A prime. And then I'll be able to work with that new slope triangle once I get there. Oh, and since the radius is 5, we know that this radius is 5. Okay, so let's solve for alpha. So I'll use the 3 and the 4, but really you could use any of the sides you want. The 3 is the opposite, the 4 is the adjacent. So I'm going to do tan, because that's opposite over adjacent. So tan of my angle alpha equals the opposite side 3. Oh. 3 over the adjacent side 4. So to get alpha, I'm going to do tan inverse. And if you plug that into a calculator, this is so slow. Here, let's try it just to review. So I need to switch the mode to degree. And then we'll do second tan alpha, or 3 over 4. Okay, so it's 36.870 when you round. Okay, so that means that theta is going to be 90, because this whole angle here is 90, minus the 34 in the alpha. So theta equals 90 minus 34 plus alpha. And that ends up being, let's see, 90 minus 34 plus that answer, 19.130. Degrees. So I'll write that in here. 19.130 degrees for that angle. So let me draw that triangle by itself, just so I have it right here. So here's the 19 point whatever, dot, 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 right? 19 degrees. We know that the radius is 5. And we need this side, I'll call that B, and this side A. So let's see, A is the opposite side. This is the hypotenuse. This is the adjacent side. So if I did, let's say, sine of 19.130, really you're just going to take the answer from before and cut and paste it there. That's going to be the opposite side, A, over the hypotenuse, 5. And then if I multiply the 5 over, equals A. Then let's see, that's 5 times sine of the previous angle right there. And we get 1.639 when you round it. And then to get the adjacent side, B, we'll do cosine 19.130 equals B over 5. And if you multiply the 5 over, that ends up being 5 cosine at 19. And we get 4.724. So if I put those in the picture, the 4.724 is the vertical part. And the 1.639 is this horizontal part. And remember, we're starting here, 0, 0 is the center point. So if I go up 4.724 from 0, 0, my y-coordinate is 4.724. If I go across by 1.639 from 0, 0, then I've got 1.639 right there. Okay, let's take a look at the next one. So the next one, it works pretty much the same way. We're going to build those slope triangles, figure out the radius and the angles, and use a bunch of trig. The only difference is the center is not 0, 0. So we're still going to do the same exact sort of thing. Let me draw a radius here. That's R. Let me draw a radius here. That's R. I know that the rotation is 82 degrees, so this central angle would be 82 degrees. And then let's build our slope triangles. So I'll build one here. And I'll build another one down here. And the only one I can work with right now is the one that's on top, the one above point P, because I know where A is. So let's see, if I'm going from 2, 3 to 4, 8, that's up 5 and over 2. And so if I do Pythag to get R, I've got R squared equals 5 squared plus 2 squared. So that means R is, that's 25 plus 4 is 29, so R is going to be root 29. So root 29 here, and root 29 here. So let's see. What else can we solve for? We can solve for an angle. And in this case, the angle that we want is this guy here, right? Alpha. Because if I know alpha, I already know the angle next to it's 82, and then I can solve for this angle right here, which I'll call theta. Ooh, that's a terrible looking theta. That angle. So let's solve for alpha. So I'll use the 2, which is the opposite side, and the 5, which is the adjacent side. So this would be tan alpha equals 2 over 5. And so alpha will be tan inverse of 2 over 5. And if you plug that into a calculator, I mean, I'm not going to bother doing it right now, but that ends up being 21.8014. So then theta is going to be 180, because notice in this case it's 180 because those three angles all add up to a straight angle. So 180 minus the 82 central angle and the alpha that we just got. Whoop, plus. And if you work that out, you get 76.1986. Right, and these are degrees here. So now if I draw that bottom triangle by itself, I know that this angle is theta. It's 76.1986. I know that the radius is root 29, and I need to solve for, like, I don't know, I'll call that A down here and B over here. So let's see. A is the opposite. B is the adjacent. This is the hypotenuse. So if I wanted to solve for the opposite side, I got to use the one side that I know. So we'll do opposite hypotenuse, that's sine. So sine of 76.1986 equals the opposite side A over the hypotenuse, root 29. If I multiply the root 29 over, we get A, and that ends up being 5.230. So this part right here is 5.230. Okay, to get B, that's adjacent, and we'll use the hypotenuse, so that'll be cosine. So let's see, root 29 cosine 76.1986 equals B. And if you plug all that in, that's 1.285. So this drop here is 1.285. So then the final coordinate, the place where A prime is, you know that you're at 2, 3 for P. That's the center point, 2, 3. And then you drop 1.285, and you go to the right, 5.230, to end up here. And so this location, when I figure out that coordinate, that's A prime. So if you think about it, when I drop 1.285, I have to take the 3, the y value, and subtract 1.285 from it. So this one is going to be 1.715. And I'll put down below here, it's 3 minus 1.285. This value right here, the x was originally 2, and then I moved to the right by 5.230. So it's 2 plus 5.230, which is 7.230. And then that's the coordinates of A prime. The only real difference in this problem is from the previous one is that you have to keep in mind where that center point is when you figure out your slope triangles and where you end up. Okay, I hope that helps a little bit.